A surprising insight that we've uncovered through our research for adversarial machine learning is how little it takes for adversaries to craft very specific inputs for fooling machine learning models. Often we'll find that the smallest changes to a file, whether it's inserting a small snippet of code, can lead to the model being completely and utterly confused. Typically, attackers poison the training data in order to interfere with the model's predictions at a later date. So this means that, for example, they will inject bad samples into the training data with the intention of causing that model to produce predictions which don't make sense. They could inject triggers within the model's training data. So this means that they can then leverage such triggers at a later date to cause the model to behave in an unpredictable or unexplainable manner. That is something which attackers have been doing, and we've seen the research pick that up quite lately. At the intersection of cybersecurity and AI research, I see an important area around adaptive defense. So what that means is defenses for machine learning systems, AI systems, which are context aware of their environment, the situation, so that they can provide the highest quality defense. So this means adapting to the latest attacker threats, adapting to their environment in a manner which provides highly intelligent and highly capable defensive capabilities. A common misconception about the role of AI in cybersecurity, of AI in general, is that it is plug and play, in that you can train or build an AI model without any further need for maintenance or monitoring of its capabilities later on. We know that for cybersecurity, where threats are ever evolving in the malware space, in the system security space, you need to ensure that any machine learning solutions you develop for detecting malware or detecting network intrusion attacks or any kind of cybersecurity application, you need to ensure that such models are monitored for decay and monitored for the problem of concept drift, which essentially means that the performance of the model has drifted from its initial release. I've had the privilege of being able to publish in various journals over the years. So 2 recent papers that I published were named Malprotect and StratDef. So they are 2 defenses for the problem of adversarial machine learning. Some lessons that we learned from this work were typically that models, when they are protected by defenses, need to be context aware. They need to be aware of their surroundings. Moreover, we found that machine learning defenses, just like in traditional cybersecurity, need to follow the paradigm of defense in depth. So this means multiple layers of defense working together in tandem to promote the highest level of immunity against any kind of attack. Security leaders of today need to pose some serious questions to their teams regarding the explainability, interpretability, and performance of AI models, as well as the security of those models. It's well known that when models are deployed in the real world, their behavior and their performance can diverge from lab conditions. So I feel this is something that should be accounted for quite significantly by security leaders.